Okay, so previously we looked at similar figures. We looked at similar polygons. And we found how those polygons compare to each other in terms of area and in terms of volume. We're going to do the same thing, but instead of comparing just shapes, we're going to compare solids. So what you're going to find is a lot of what we're going to do today should be familiar because we've already done it. It's just the way we're applying it is going to be different. So basically the first thing that we did and the first thing that we're going to do is identify similar solids. In other words, are these shapes similar? And the same way we did it when we talked about two-dimensional shapes, we're going to do it when we talk about three-dimensional shapes. Basically what you're going to do is you're going to compare the sides of one figure to the side of the other figure. And if they are all in proportion, we know they're similar. So if you take a look at this one here, and I'll make it bigger if I can. This is about as big as I can make it. So you can see, if we take the left-hand side here, if I take this side here, I'm going to compare it to this side here. That's terrible. So the side on the side, so to speak, is in a ratio of 3 to 6. Then I look at the bottom. So the bottom of this one is 3. The bottom of the big one is 6. 3 to 6. And then I look at the one going up in that direction, up towards the sky. The little one is 2. The big one is 4. If you compare 3 over 6 and 3 over 6 and 2 over 4, if you simplify them all down, you will see that they all equal a half. So these two solids are similar because the second one, each side is twice as big as the corresponding side on the first one. If you come over here and you do the same thing, look what happens. My first side, which is the vertical side on the left, it's 2 on the little one and 3 on the big one. If I go to the side going upward at a 45-degree angle on the right, that's 2 and that's 3. So far so good. But if you look at the edge at the bottom, this is 3 and this is 6. Since 2/3 does not equal a half or 3/6, we can then say that those figures are not similar. And that's really all you have to do, is you have to simply compare. So just to identify, all you have to do is compare. Anybody have any questions about this so far? All right. Now, I touched upon this. Okay, so if I have two similar solids, okay, and let's just pretend so I have two prisms, and the rays, just like the one we just did, where the little one is half the big one. When you're talking about area, you're talking about 2 dimensions. So the area, to find the area of each figure, you're going to square the ratio. So you can see that if the sides are 1 to 2, the area is 1 to 4. What do you think it's going to be if I'm talking about volume? Volume is how many dimensions? be to the third power, or 1 to 8. So if you're told what the length of the side is, or the ratio, you can get the ratio of the volume by simply cubing both parts of your ratio. And the same thing with finding the area. You're going to square it. This is a good way to remember. For comparing the sides, it's one-dimensional, so everything is to the first power. Comparing area, second dimension, everything is to the second power. Volume, 3 dimensions, everything is to the third power. Okay, does anybody have any questions? Is anybody not done copying? All right, so what we want to do is we want to find the scale factor. Okay? So what's important is to look at what units they're giving us. So in this particular case, they're telling us the volume. Okay? So we have to remember, what is the ratio of the volume? It's it's to the third power, right? 1 to 8. Okay, so what you're going to do is you're going to set up your ratio of little to big. So the volume of the little one is 729. The volume of the big one is 1331. Okay, so we know that since it's volume, we take the ratio of the sides and we cube them. So now, since this is the number cubed, how do we find the underlying value? What? Not divide by 3, not multiply. If I have something like in the Pythagorean theorem and I had something squared, how did I find that value? What? Find the square root. So if I had something raised to the second power, I found the square root. What if I have something raised to the third power?
Find the square root.
Jonathan? The cube root. So all I have to do is find the cube root. Now all your scientific calculators all do this. So all you have to do is find the cube root of 729. You plug that in your calculator, cube root of 729, which is 9, and the cube root of 1331, which is 11. So the scale factor for these two figures is 9 to 11. Okay? Okay, if there are no questions, please do the classwork problem. Now, look closely. I'll give you a hint. It's not talking about volume. Okay, so we are told that the lateral area of two similar paint cans are 1,019 and 425 square centimeters respectively. We're told that the volume of the smaller can is 1157. We want to know the volume of the larger can. So this is a multi-step problem, because first we have to find one thing, then we have to find something else. So the first thing that we have to find, step number 1, is to find the scale factor. Okay? All right, so we start off with the ratio of the surface areas. So we have the ratio of the surface area, which is a squared to b squared. book uses big over little. So the book uses 1019 over 425. Now, if this is the ratio of the area, how do I find the scale factor? What do I have to do to these two numbers?
Square root.
Take the square root. So if a squared over b squared is 1019 over 425, then a is the square root of 1019 over the square root of 425. Okay, this is a little complicated, so please pay attention. Okay, now, this is the scale factor. So now I'm going to use this. This is step number 2, is find the ratio of the volume. Notice I'm not putting those into my calculator. So if this is my scale factor, how do I find the scale factor of the volume? What power do I need to raise those numbers to? The third power. So the ratio of the volume is this number, whatever the square root of 1019 is, raised to the third power, divided by the square root of 425 raised to the third power. And because of the types of numbers we're dealing with, you don't want to get decimals for those. Okay? Okay, now, so we can say that this is equal to the volume of the large figure divided by the volume of the small figure, right? Yes? No? Maybe? Now, what do we know, though? Out of these two things, the problem tells us one of them. The problem tells us that the volume of the smaller can is 1157. So what I'm going to do is I'm going to erase that, and instead I'm going to put 1157. That's why it's important that it will make the problem easier for you if after you get these numbers, and again, do not put these in your calculator yet. Write down what each one of them is, because they're going to give you the value for one of them. Now you should see what is the next step to do here. The next step is to what? What do I have here? What do we call this thing? Two things that equal each other.
One equal the same other one.
Starts with the letter P. Proportion. We have a proportion, and how do we solve proportions? So we're going to simplify, and we're going to do the volume of the large, which you can substitute x for, or some other letter, times the square root of 425 raised to the third power is equal to 1157 times the square root of 1019 raised to the third power. What's the matter now? I'm confused. I did. I cross multiplied. I did these two and these two. Okay, now we're going to solve for the volume of the large. So we're going to do this divided by the square root of 425 raised to the third power. We divide both sides by the square root of 425 raised to the third power. Once you get to this step, now you plug all those numbers into your calculator. So now you're going to do the square root of 1019 raised to the third power, whatever that is. You get that number, leave it in your calculator. Don't round it. just hit the calculator and then just hit times 1157, because your calculator will do answer times 1157. It equals, that's going to give you some number. You then hit divided by, because your calculator again will just pull up the answer. You don't have to worry. You just type in this stuff. And then hopefully you'll come up with the right answer. In this case, it's 4,295. So the volume of the lard is about 4,295 cubic centimeters. That's a 4, by the way. Okay, this is a tricky problem because you have to remember to take the square root and then raise it to the third power. So it's kind of different from anything that you've seen before. What? It's very important, though, that you try this on the homework tonight. Not as much as it